Hey guys, welcome back to the Hewlett-Packard 8444A project. I bought this as a companion to my Hewlett-Packard 8568B spectrum analyzer. So the spectrum analyzer on its own will, analyze the spectrum. It will look at whatever signal you're feeding into it over a specified range of frequencies. It doesn't output anything. If you pair it up with a tracking generator, this will output something. This will output a signal at the same frequency that this device is currently looking at. The idea being, you can use it for alignments or analyzing a circuit. You feed a signal in to your device under test, and you check the output, and you feed it into the unit on the bottom, and it will show you the frequency response. So imagine it's an audio amplifier. You could go from 20 hertz to 20 kilohertz. Feed a signal in, check the signal out. If it's perfect amplifier, the output level should be flat across the range of frequencies. Or if you're doing an IF alignment, you can peak it for a certain frequency. You do all kinds of analyzing of circuits in the frequency domain. Okay, so when we last left off, I had acquired this off of eBay. It does not have option 59, which after reading and doing a bit of research, I confirmed is essential for it to work with this spectrum analyzer. So, how do we make it work without it? Well, Curious Mark, if you don't know him, he's another YouTuber, been around for years, done many videos on vintage test equipment, some really cool stuff, the NASA lunar lander computer, very knowledgeable guy. And he's influenced me, he inspired me to get some of this gear. Like he restored an 8662, he restored an 8568B, and he paired it up with the 844A, so I am following in his footsteps. And in his video, he does have option 59, and he confirms that it works, and then he disconnects it and he feeds it with an 8662 because this is a better reference oscillator. It's more stable. And he was able to get even better accuracy out of this than Hewlett-Packard claims it can do. So let's try doing the same thing. Now I have confirmed that the problem with this is it's a flaky power switch. It's supposed to toggle on, toggle off. It does not. However, if you hold it pressed down, the DC voltages on the internal power supply are dead on. I think it's plus 20 volts and minus 10 volts. So it does seem like the power supply is fine, and the problem is just with this switch. I have the part number, I googled it, there was a used one for sale on eBay a while ago, otherwise I don't see any talk about it anywhere. So a little disappointed by that because Hewlett-Packard, Tektronix, etc. have a pretty solid following, and a lot of folks like myself are trying to keep these running. And there's plenty of articles about them in the forums, discussions about keeping them running and maintenance and whatnot. I thought somebody would have come up with something to replace that switch with. But, oh well, I'll just hold it down. So here's what we're going to do for starters. We're going to take the output. Well, first let me tell you how I hooked it up. So this needs a first LO and a third LO local oscillator. Frequency is coming out of the spectrum analyzer. Problem is the 8568B only does a first LO output. There's no third LO output. Anyways, the first LO output on this is on the far right side on the bottom unit. I climb up on the workbench, hooked up a BNC cable to it, and pulled it around, and it goes into an input on the front of this device. So output of this, first LO, input of this. That's what does the sweeping. It's something like 2 to 3 gigahertz. And then you need the third LO, which is just it's a fixed 500 megahertz oscillator. What this does is some heterodyning to shift the varying IF frequency out of this into the range that you're interested in. And this base unit will go from 0.5 to 1300 megahertz. I found out, by reading the manual, that option 59 doesn't just have a reference oscillator inside. It also, two of the filters get upgraded to extend that to 1500 megahertz to match what the spectrum analyzer can do. I don't mind losing a couple hundred megahertz. But the point is, you absolutely do need that 500 megahertz oscillator, or so I think. So let's first try it without it. Things are going to get noisy, so bear with me. All these devices have their own cooling fans. So spectrum analyzer on, scope on, and I'm not using a probe, I'm just going 50 ohm output to 50 ohm input on this guy. And by default, this is going to scan from 0 to 1500 megahertz. Let's shave that down to something a little more manageable, like 20 to 30 megahertz. Still learning how to use this device, but I think I can manage that because they label it pretty clearly. Start frequency to 0 megahertz. Stop frequency 3 to 0 megahertz. So what does it mean? It means that this device now is scanning 20 on the left side, 30 on the right, and it's like tuning a radio and rocking the dial back and forth, and it's looking for whatever's coming into it. I'm not feeding anything into it right now. However, it's also paired up to the tracking generator, so as it's listening for 20 to 30, this should be outputting 20 to 30 and sweeping back and forth to whatever my current sweep rate happens to be. So, if we look on the scope, I'm going to sneak over in front of the camera and hold that power button down, and let's see if anything appears on the scope. So, here we go. Turning it on. No. Let's see, I'm on 100 millivolts per division. That's pretty sensitive, but we can do better. Let's go all the way down to 2 and turn it on. Okay, we get some fuzziness. It's doing something. But as I suspected, you need that reference oscillator. I was hoping initially that you only needed it to get this full specs up to 1500 and it would go up to 1300 without it, but reading on the theory of operation and all that, yeah, you need it. Okay, well, where can we get that? We get it from the 8662A. Alright, so let's fire that up. Now it's really going to get noisy. I already dialed this into 500 megahertz. Don't know what the amplitude should be. Let's do minus 10 dB. Okay, output of that. Go into the third LO. Now there's a third LO input on both the front and the back of this device. So I'll use the one on the front, that's handy. So, okay. Well, let's go back and look on that scope again. And I'll turn the 8444 on. And, oh! I'm still on that super sensitive range. Let's turn that down, do 1 volt per division. Let's see, output level up all the way. Okay, let's go down a bit. Look at that. It's sweeping. And if I change the scan rate on spectrum analyzer, it should slow down sweep time. Down, I'm increasing the sweep time, meaning sweeping slower and slower. Absolutely, and that's beautiful looking. Now you've seen me do alignments before, so you might be thinking, well, what's the big deal? Why am I overcomplicating things with all this stuff? Well, let me talk a little bit about this device. This is a digital synthesized signal generator. Outstanding features in general. Puts out a super clean, super stable signal. And there's lots of options for sweeping. However, notice one of the settings under sweep is steps. 100 steps, 1000 steps. What that means is if I sweep, and say I'm going from that 20 to 30 megahertz, it doesn't do it in the analog manner. It's not a continuous sweep. It's not perfectly smooth like this is. It's discrete. It'll say go from 20 to 30 in 100 steps. Like it'll do 20 and then 20.1 then 20.2, then 20.3, and it jumps. There's a discontinuity between as you jump up in frequency. That is not ideal when you're doing alignment, because when you jump frequencies, it introduces a little spurt of harmonics of noise as it's jumping. Plus, you lose some detail. And if you do the 1,000 steps, the sweep rate goes down, it goes slower. This device is pure analog, beautiful sweep. Now, what I want to try doing, I don't have my active probe yet. I'm not going to probe around any active circuits until I have that probe, so I don't want to damage my spectrum analyzer. However, if I take the output of the tracking generator and feed it back to the input of the spectrum analyzer, I should get a straight line, because it should have equal amplitude as it's sweeping that range. Now this is a very small sweep range, and you can see that sine wave sure looks like it's staying the same amplitude as it's going across the frequencies. So let's see if we can do that. And then once you're at that point, you put a device in between and you should see the response curve of it. Alright, so let's take the output from the scope, turn it off. There's some of this fan noise. Oh yeah, made no difference whatsoever. The 8662 is the real beast. Well, the spectrum analyzer is pretty loud too. Okay. So let's turn this on. Oh, beautiful. Let me try to get you a better view of that. So, holding down the button now. And there we go. And if I vary the output level of the 8444, it should go down. And there she goes. And boy, that is pretty darn flat. Now, if it was off, there is a tracking adjust, and I just tweaked it. And now it's going down and down and down. What that does is it's an offset to keep these things in perfect step. So when you're listening at 20 megahertz, this is outputting 20 megahertz. And you know they're good when that line is flat all the way across the screen. Let's try increasing that sweep range a little bit. See how flat that stays. So let's do a start of, let's go 1 megahertz, and let's do a stop of 100 megahertz. Much larger range now. And turning it on. That's really impressive. There's some slight waviness to it, especially at the very start. Let's go even bigger. This thing is characterized from 100 hertz to 1.5 gigahertz, so let's do it. So now we're going 0 to 1500, the entire range. Now this tracking generator doesn't go up to 15 hertz, so I expect it's going to have some problems, but here we go, turning on. That's a lot better than I thought it was going to be. And as Curious Mark showed, there is a mode so you can capture that squiggly line and apply it as an error correction offset and get a perfectly flat line. I'm going to tweak that tracking generator a little bit. Interesting, it's not having an effect. Oh, okay, now, yeah, it is, okay. It's just, there was just a huge range, yeah. The effect was a bit subtle, so I didn't see it at first. Alright, let's go back to something a little more manageable. And 20 to 50 megahertz. Turn it back on. Nice. I can't wait to try using this. Because the other cool thing you've got is markers. Now that's something else I need to study up a bit on. I know you can do one marker very easily. What I don't know is, can you do multiple markers? Okay, there we go. So the normal marker mode, you got this knob, and it puts a dot wherever you're looking at. So I know that right now I'm at 34.65 megahertz. So imagine we've got a response curve up there. If I want to know at what point something's at, I can rotate this around. Or I can set the marker to say 455 kilohertz and leave it there, and then tweak my alignment so I get a peak where the little dot is. But what I need to read up on is, can you program in multiple markers? And if you can, boy, that'll be handy. Most typically for a video signal there are 4 or more key frequencies they outline, and if I can program those all in and I get a nice little dot and a readout next to that dot, that'd be a wonderful thing. But even like this, where you've got a single marker, it's still really, really nice. Also notice there's a marker delta step size. So I get a feeling that you can set this up to do like a marker every 10 megahertz or every 1 megahertz. You can also do a peak search. Not much point right now, but if I had a meaningful signal where there was a peak in it, I could hit that and it would tell me automatically what the frequency is where the peak exists. Very cool. And now I have to wait with bated breath because it will likely be at least a week and a half, 2 weeks before the probe arrives. It hasn't even shipped yet. The Memorial Day weekend is delaying things. So we will just have to be patient. That's going to be it for now. If any of you have any tips, suggestions, or advice, I'd love to hear them.